Hello, welcome to our channel for probability and statistics. In this video, we will talk about estimating the difference between two means with unknown but equal variance. So if we want to estimate the difference between two population means, and these two populations both have approximately normal distribution with mean mu1 and mu2, and their variance are unknown, but we only know their variance are same. So their variance sigma 1 equals sigma 2 equal, say, sigma square. So this is statistic which equals x1 bar minus x2 bar minus the difference of mu1 and mu2, then divided by sigma square times 1 of n plus 1 of n2. So this statistic has a standard normal distribution. And we can also know according to the theorem of sampling variance. So this part n1 times minus 1 times s1 square divided by sigma square and n2 minus 1 times s2 square divided by sigma 2 square. Both have chi-squared distribution. So with n1 minus 1 and n2 minus 1 degrees of freedom. So n1, n2 are sample size for population 1 and population 2, right? And S is the sample standard deviation. So because they are both independent, so from the chi-square distribution characteristic, they are independent, we can sum them together. So the summation of both is also chi-squared distribution random variable with n1 plus n2 minus 2 degrees of freedom. So from the t-distribution definition, the t statistic here, which is the division of two statistic. This one has a standard normal distribution, and this one has chi-squared distribution divided by its degrees of freedom and take a square root. So these two parts has a t-distribution with the n1 plus n2 minus 2 degrees of freedom. So if we substitute a weighted average of the two sample variance in the t statistic, where SP is pooling sample variance S1 and S2, then we can obtain a simple form x1 bar minus x2 bar minus the difference of the mu1 and mu2, then divided by the pooling of sample standard deviation times square root of 1 of n1 and 1 of n2. So this statistic has a t-distribution with n1 plus n2 minus 2 degrees of freedom. So in this form has no sigma, right? Because we do not know the sigma's value. So we only know the sample standard deviation. So from this form, we can go further. We can get the confidence interval of the population mean difference, mu1 minus mu2, which is between a lower bound and upper bound. And the lower bound and upper bound is just the sample mean difference minus and plus a term. This term is the t critical value at half alpha level, then times the pooling standard deviation of the sample, then times 1 of n1 plus 1 of n2, take a square root. So next we will see an example. Two independent sampling stations were chosen for this study. One located downstream from the acid mine discharge point and the other located upstream. For 12 monthly samples collected at the downstream station, the species diversity index had a mean value x1 bar 3.11 and a standard deviation S1 0.771, while 10 monthly samples collected at the upstream station had a mean index value x2 bar 2.04 and a standard deviation S2 0.448. So the question is, find a 90% confidence interval for the difference between the population means for the two locations, assuming that the populations are approximately normally distributed with equal variance. So from the problem description, it is quite clear it satisfies the needs of what we have learned from the previous pages for confidence interval for the population difference. So we let mu1 and mu2 represent the population means. Then for the species diversity index at the downstream and upstream stage. Then we wish to find 90% confidence interval for the mu1 and mu2. And our point estimate of the mu1 and mu2 is the sample average difference x1 bar minus x2 bar, which equals 1.07. And the pooled sample variance in this form equals 0.417, because we have found S1 square and S2 square from the problem description, right? Then next we can further get the confidence interval of the difference between population means equals about 0.593 and 1.547. Thanks for watching.